everyone, this is Kalpana here. In this video, we're going to solve the given differential equation. So, let's get going. Problem. Solve 4x plus 3y plus 1 into dx plus 3x plus 2y plus 1 into dy equals to 0. Solution. Given differential equation. Four x plus 3y plus 1 into dx plus 3x plus 2y plus 1 into dy equals to 0. You can write this as 3x plus 2y plus 1 into dy equals to, take this to RHS, minus of 4x plus 3y plus 1 into dx, right? Now, get this dx to LHS and take this to RHS, you'll get dy by dx equals to minus of 4x plus 3y plus 1 by 3x plus 2y plus 1. Now multiply all these three terms with minus. We'll get dy by dx equals to minus 4x minus 3y minus 1 by 3x plus 2y plus 1, which is in dy by dx equals to a1x plus b1y plus c1 by a2x plus b2y plus c2 form, which is non-homogeneous form, right? And also this is of dy by dx equals to some function of x, y, right? Consider or like this as function of x, y. If f of kx, ky equals to f of x, y, then we can say that this function is homogeneous function. Then the differential equation involving homogeneous function will be called as homogeneous differential equation. If this does not happen, then we'll call it as non-homogeneous function. Then the given equation or this equation will be called as non-homogeneous differential equation. Since the differential equation involves a non-homogeneous function, so we'll call this differential equation as non-homogeneous differential equation. Okay, you can check it by putting x equals to kx and y equals to ky. Since we are having constants minus 1 and plus 1, so there is no possibility of cancelling k from numerator and the denominator. Okay, if you want, I'll show you. Put or replace x by kx and y by ky. This is a function of x, y, right? Then we'll get minus 4kx minus 3ky minus 1 by minus 3kx plus 2ky plus 1. See, we don't have k in all these three terms, so that we can't take k common from all these three terms in the numerator and also k from all the three terms in the denominator, and there is no possibility of cancelling k from numerator and denominator to get f of x, y, right? So we can say that f of kx, ky is not equals to f of x, y. So from this we can say that the given equation is a non-homogeneous differential equation, right? The given equation is non-homogeneous. Fine. Now, By comparing these two, we'll get the values of a1, b1, c1, a2, b2, c2, right? From the numerator, the quotient of x will be our a1. Okay? Quotient of x is our a1. And quotient of y is our b1. And c1 equals to minus 1. Now coming to the denominator, quotient of x is your a2. Quotient of y is b2. Okay, and c2 equals to 1. Fine. Now let's find a1 b2 minus a2 b1, which is equals to a1 minus 4 into b2 2 minus a2 3 into b1 is minus 3, which is equals to minus 4 2s are 8, minus into minus plus 3 3s are 9, which is equals to 9 minus 8 equals to 1, which is not equals to 0, right? Therefore a1 b2 minus a2 b1 is equals to 1, which is not equals to 0, or simply a1 b2 minus a2 b1 is not equals to 0. Since a1 b2 minus a2 b1 is not equals to 0, so we'll solve the given equation or consider it as equation 1, okay? Or better, consider it as equation 2 and given equation as 1. This is also the given equation, but we have written it in dy by dx equals to a1x plus b1y plus c1 by a2x plus b2y plus c2 form. Okay, now we'll solve equation 2 by putting x equals to capital X plus h and y equals to capital Y plus k. Okay, we have x equals to capital X plus h, right? If we differentiate both sides with respect to capital X, then we'll get dx by dx equals to derivative of capital X with respect to capital X is 1, or simply, okay, plus then we'll get dx by dx equals to derivative of capital X with respect to x is 1 plus derivative of a constant with respect to x is 0. So from this we'll get dx by d capital X equals to 1. From this, d small x equals to d capital X, right? Then d small x equals to d capital X. Now consider y equals to capital Y plus k. Again, differentiate on both sides with respect to capital Y, then you'll get dy by d capital Y equals to d capital Y with respect to dy plus d constant with respect to y. Okay, derivative of capital Y with respect to capital Y and derivative of a constant with respect to capital Y. We'll get dy by d capital Y equals to derivative of capital Y with respect to capital Y is 1 plus derivative of a constant with respect to y is 0. From this we'll get dy by d capital Y equals to 1. Again, dy equals to d capital Y into 1 is d capital Y, that is differential capital Y, right? Fine. Now, what about dy by dx? Dy by dx will be equals to replace dy by differential d capital Y by replace dx by differential d capital X. Okay, now equation 2 becomes dy by dx can be replaced by d capital Y by d capital X equals to minus 4 into x, that is capital X plus h, minus 3 into capital Y. Sorry, minus 3 into y. Replace y by capital Y plus k minus 1 by 3x. 3 times capital X plus h plus 2y plus 2 into capital Y plus k plus 1. Right? Now this equation becomes dy by dx equals to minus 4x minus into plus minus 4h minus 3y minus into plus minus 3k minus 1 by 3x plus 3h plus 2 into y, 2y plus 2k plus 1. Again, you can write this as, firstly you will write x term and y term, minus 4x minus 3y plus all the remaining 3 terms, minus 4h minus 3k minus 1 by, again write x term and y term, 3x plus 2y plus all the next 3 terms, okay, remaining 3 terms otherwise, 3h plus 2k plus 1, which is in, this is capital Y and capital X, okay. We have replaced it, right? Which is in dy by dx equals to a1x plus b1y plus a1h plus b1k plus c1 by a2x plus b2y plus a2h plus b2k plus c2 form. See, we are having the quotient of x and h a1, right? a1 is minus 4. Quotient of h and x is minus 4. Now, check quotient of y and k is minus 3. Okay, quotient of y and k is b1. We should get b1 equals to minus 3. Fine. And here you'll get c1. Okay, you got, fine. And quotient of x and h in the denominator will be a2, 3. Likewise, quotient of y and k is b2. b2 is 2. Quotient of y and k in the denominator is 2. And c2, 1. Fine. Okay. So this is in this form. We can consider it as equation 3. Now, we need to choose h and k such that these two polynomials become 0, which is nothing but minus 4h minus 3k minus 1 equals to 0 and 3h plus 2k plus 1 equals to 0. Okay. Now, by solving these two equations, we'll get the values of h and k. Okay. So we use cross multiplication method to solve h and k. Okay? Cross multiplication method to solve these two equations. Okay, we can name it as some equation A and this as some equation B. Fine. Consider two equations. Minus 4h minus 3k minus 1 equals to 0. 3h plus 2k plus 1 equals to 0. So here is the method. H, k1 minus 3, 2, minus 1, 1, minus 4, 3, again, minus 3, 2. See, we have B1, just compare these two. Okay, here we are having B1 minus 3 is your B1 and is your C1, A1, B1. We'll take randomly 3. 3 must be your A2. A2 is 3. This one must be B1. B1 is minus 3. Fine. Okay. So now we'll do cross multiplication. H by minus 3 into 1. Minus 3. 2 minus of minus 1. Minus of or minus 2 into minus 1 is minus 2 equals to k by minus 1 into 3 minus 3 minus of 1 into minus 4. 1 into minus 4 is minus 4 equals to 1 by minus 4 into 2 minus 8 minus of 3 into minus 3 is minus 9. Right? We'll get h by minus 3 minus into minus plus 2 equals to k by minus 3 minus into minus plus 4 equals to 1 by minus 8 minus into minus plus 9. That is h by minus 3 plus 2 is minus 1 equals to k by 4 minus 3 1 equals to 1 by 9 minus 8 is 1. Okay. Now equate first and second one, or simply you can write this as h by minus 1 equals to k by 1 equals to 1 by 1 1. Now equate h by minus 1 and last one 1. From this we'll get h equals to minus 1 into 1 is minus 1. And now equate these two. K by 1 equals to 1. From this we'll get k equals to 1 into 1 is 1. Now if we substitute these values in these two polynomials, it should become 0. So we'll see. Firstly consider this, or you have to get these two. Okay. Firstly consider minus 4h minus 3k minus 1 equals to 0. Consider the LHS part. Minus 4h minus 3k minus 1, which is equals to minus 4, into substitute the value of k minus 1 minus 3 into substituted the value of h. Next we have to substitute the value of k, which is 1. Minus 1 equals to minus 4 into minus 1 is 4. Minus 3 into 1 is 3. minus 1, which is equals to 4. Minus 3 minus 1 is minus 4. 4 minus 4 is 0, right? So we got this. That means this polynomial became 0. Now let's check the second one. That is equation B should happen. 3h plus 2k plus 1 must be equals to 0. Okay, fine. Now let's substitute the values of h and k. For h equals to minus 1 plus 2 into, for k equals to 1 plus 1, this equals to minus 3 plus 2 plus 1, which is equals to minus 3 plus 2 plus 1 is 3, minus 3 plus 3 is 0, right? So here also we got 3h plus 2k plus 1 equals to 0, which means that our h and k are correct. Okay. Therefore, h equals to minus 1 and k equals to 1 such that minus 4h minus 3k minus 1 equals to 0 and 3h plus 2k plus 1 equals to 0. Okay. Now, equation 3 becomes 3 becomes d capital Y by d capital X equals to minus 4x minus 3y plus this is equals to 0, right? Since minus 4h minus 3k minus 1 equals to 0 after substituting h and k values by 3x plus 2y plus this also equals to 0, right? Then dy by dx equals to minus 4x minus 3y by 3x plus 2y, right? So dy by dx equals to some function of x and y. This is dy by dx equals to some function of xy form, right? That function of xy will be minus 4x minus 3y by 3x plus 2y if f of kx ky equals to, that is function of kx ky equals to function of xy, then we can say that this function is a homogeneous function. Then we call the differential equation involving the homogeneous function as homogeneous differential equation. So let's check f of kx ky, which is equals to, simply replace x by kx and y by ky in function of xy, then you get minus 4 kx minus 3 ky by 3 kx plus 2 ky, right? Now we can take k common from the numerator and the denominator as well. So you get k times minus 4x minus 3y by k times 3x plus 2y. Here k gets cancelled and you'll get minus 4x minus 3y by 3x plus 2y, which is a function of xy, right? So from this we can say that therefore function of kx ky equals to function of xy. Since function of kx ky equals to function of xy, from this we can say that this function is a homogeneous function and the differential equation involving homogeneous function is called homogeneous differential equation. So from this we can say that the given non-homogeneous differential equation is reduced to a homogeneous differential equation. Okay, just name it as equation number 4. Okay, fine. Now you can solve this equation simply using homogeneous procedure by taking y equals to vx. Okay, simply put, y equals to vx to solve the given differential equation. To solve the reduced homogeneous equation. Now differentiate this on both sides with respect to x. You will get derivative of vx with respect to x. Here you can use u v whole dash formula, which is equals to u dash v plus v dash u. Right? Then you'll get dy by dx equals to derivative of v with respect to x into x plus derivative of x with respect to x into v. So from this we'll get dy by dx equals to x into dv by dx plus 1. Derivative of x with respect to x is 1 into v. Okay. If y equals to vx, then dy by dx will be 1 into v plus x into dv by dx. Now we'll replace dy by dx by this and x by this. Then equation 4 becomes replace dy by dx with v plus x into dv by dx equals to minus 4x minus 3. Replace y by vx by 3x plus 2. Replace y by vx. Okay. Now v plus x into dv by dx equals to, take x common from the numerator, x times minus 4 minus 3v by, also take x from the denominator, x times 3 plus 2v. Now we can cancel x, we'll get v plus x into dv by dx equals minus 4 minus 3v by 3 plus 2v. Now take this v to RHS, you'll get x into dv by dx equals to minus 4 minus 3v by 3 plus 2v minus v. Then x into dv by dx equals to minus 4 minus 3v minus v times the denominator 3 plus 2v by 3 plus 2v. Simply we'll take the LCM. Okay. Then this equals to minus 4 minus 3v. Minus v into 3 is minus 3v. Minus into plus minus. V into 2v is 2v square by 3 plus 2v, which is equals to minus 4. Minus 3v is minus 6v minus 2v square by 3 plus 2v. Now we can take minus 2 common from all the three terms, the denominator. Then you'll get x into dv by dx equals to minus 2 times 2 plus 3v plus v square by 3 plus 2v. Now we'll separate the variables. Since you're having dv, the numerator of LHS, so we'll take all the functions of v to LHS into dv and functions of x into dx on the other side. We'll get 3 plus 2v by 2 plus 3v plus v square into dv equals to minus 2 by x into dx. So here the variables are separable. Now we can integrate on both sides. Integral 3 plus 2v by 2 plus 3v plus v square into dv equals to minus integral 2 by x into dx. Okay. Since we know that integral f dash of x, or let's take variable v, by f of v into dv equals to log mod f of v plus integral constant c. Okay. Let f of v will be, take f of v equals to 2 plus 3v plus v square. Then what will be f dash of v? Derivative of f of v will be derivative of constant with respect to v is 0 plus derivative of 3v with respect to v is 3 plus derivative of v square with respect to v is 2v, which is equals to 3 plus 2v for numerator, right? So the integrand is of f dash of v by f of v form, right? F dash of v by f of v form. Now we can apply this formula to the LHS integral. Okay, then this becomes log mod f of v, that is 2 plus 3v plus v square equals to minus, okay, you can write minus integral 2 by x dx as minus 2 integral 1 by x dx, which is equals to minus 2 integral 1 by x dx is log mod x, right? So we'll replace, or this becomes minus 2, that is minus integral 2 by x dx is minus 2 log mod x plus integral constant c. Since we are having two terms in log, so we'll write integral constant as log c. Okay, then log v square plus 3v plus 2 equals to minus 2 log x plus log c, right? You know that m log n equals to log n power m. Then you can write this as, that is the first term in RHS as log x power minus 2 plus log c will be as it is. Since we know that log a plus log b equals to log ab, then this becomes log c into x power minus 2, right? Also we know that if log a equals to log b, then a equals to b. See, we are having log A equals to log B. Then this becomes A equals to B. V square plus 3v plus 2 equals to C into x power minus 2. We know that x power minus n can be written as 1 by x power n. Then we can write x power minus 2 as 1 by x square. Okay. Also we have y equals to vx. Right. We are having y equals to vx. From this we'll get v equals to y by x. If vx equals to y, from this we'll get v equals to y by x. Now replace. Since v equals to y by x, we can replace v by y by x. Then we'll get y by x whole square plus 3 times y by x plus 2 equals to c by x square. Then y square by x square plus 3 or 3y by x plus 2 equals to c by x square. Take the LCM of x square, x and 1. X into x square, x into 1x, 1, x into 1, x into x square is the LCM. In the numerator we'll get y square plus 3xy plus 2x square equals to c by x square. Here x square from the denominators gets cancelled. Then y square plus 3xy plus 2x square equals to c. Okay. But we have small x equals to capital X plus h, or you can just rewrite it as capital X equals to x minus h. Since we have h equals to minus 1, so replace h by minus 1, you'll get minus of minus 1 equals to x plus 1. So now we can replace x by small x plus 1. Okay, and also we have small y equals to capital Y plus k. Capital Y plus k equals to y. From this we'll get capital Y equals to small y minus k. Since k equals to 1, replace k by 1, then you'll get capital Y equals to small y minus 1. Now what we need to do is, we'll replace capital X and capital Y in terms of small x and small y. Then this becomes small y minus 1 whole square plus 3 times x plus 1 into y minus 1 plus 2 times x plus 1 whole square equals to c, which completes the problem. Therefore, the general solution or the required solution of the given equation or equation 1, we have named the given equation as 1, is y minus 1 whole square plus 3 times x plus 1 into y minus 1 plus 2 times x plus 1 whole square equals to c. Okay, this completes the problem. So we have seen a problem from non-homogeneous equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.